Today, I want to introduce you to a company called Delta Robotics. As you may know, I'm the founder of OpenMuscle, Tori. I've been working on OpenMuscle, which is an open source prosthetic sensor suite that uses machine learning to predict finger movements. Now, I started with pressure sensors, moved to EMG sensors. Now, I have been working on a dev kit. Now, while I was working on this dev kit, this company, Delta Robotics, reached out to me. Now, they're producing Nitinol artificial muscles, and they are releasing a controller that is open source that actually applies the electricity, heats it up to then contract. So their artificial muscle system is aiming to actually bring this technology into the hands of other makers, make it more known, and bring it out of the lab. And that's why I wanted to introduce you guys to them, because I think what they're doing is amazing.
My name is Kevin Feer. I am the original founder and kind of the evil genius behind starting this whole process.
I'm Mark Dannemiller. I design all of our PCBs, write all the software. I'm the embedded engineer on the team.
I'm Christopher Olmer. I'm the chief medical officer for the company. So I basically look over our medical endeavors, talking to prosthetic companies and figuring out how we can take this technology and put it in some type of medical device.
He actually knows where all the muscles are supposed to go. I think that's pretty critical when we're building prosthetics, but
yeah, I do have my bachelor's degree in kinesiology, so some of that helps out, and I am going to get my master's in orthotics and prosthetics.
Right. We're building artificial muscles, so we need someone who's an expert in real muscles too.
Yeah.
So tell us, what are artificial muscles and how do they differ from linear actuators that are currently used?
Great question. So an artificial muscle is a pretty broad term. As a whole, an artificial muscle is an actuator designed to mimic biological movement, either in flexibility, contraction, speed, form factor. Our specific Thermoflex brand is a shape memory alloy that can be programmed into a specific shape. When the alloy is deformed, stretched, or moved, applying an electric current to the material, heating it up, will cause it to activate into its programmed state from martensite to austenite phase. When that contraction happens, it has a lot of force that kind of brings the whole system together.
It's a metal, but it's a memory metal. So you can stretch it out, and then when you heat it back up, it goes back to the state that it remembers. And so a lot of what we're doing is, first, how do you make the actual shape? How do you get it into this point so that it wants to go back to exactly the shape that you want it to be in? And then past that, how do you electrically control that muscle in order to produce motion that's useful for a robotic system? So currently we're looking for beta testers for our first version of our product, which is going to include one of our control boards. And we have all of our software open source for these boards. We're currently working on that firmware, and we would love collaboration on it as well, since it's a completely open source project. And we're also going to send the first versions of our muscle system, which is a Thermoflex Duo. And so if you purchase a kit, you'll get one controller and two muscles, which is, enough to build, for example, a bicep and a tricep system. And yeah, if you buy that and join our Discord server, then we can collaborate. And then our final products will also be releasing sometime in the next couple of months.
So when we originally founded Delta Robotics, we knew that traditional actuator technology just wasn't going to cut it. With humanoid robotics, bionics, and all these other technologies that are developing very, very quickly and gaining a lot of traction, we knew that traditional actuators, again, weren't going to cut it. To get the kind of motion, the fluid process in which those contractions happen. And so we decided that we were going to build something using a technology that had been in the lab forever and make it a reality and bring it down to earth for people to get a hold of and start building better, more biomechanically accurate systems.
I hopped on the team, I think a little over 2 years ago now. I've always been very interested in prosthetics. That's kind of my whole career path, even before I got involved in Delta. And so for us at Delta Robotics, there's a very clear there's very clear application for shape memory actuators in the prosthetic space. They're lighter, oftentimes they have better force to rate ratios. And so, the prosthetic field is very archaic in terms of where it's at right now technologically. It lags behind almost every other industry. The most ubiquitous version of an arm prosthesis that you'll find has its original patents dating back to 1860. So, not much has really changed. And a lot of people are very surprised by that. They're like, what? Like, that can't be true. But, you look at the most used prosthetic today for arms, and you look at that 1816 patent, really the only thing that has changed is the materials, and that's really about it. It doesn't matter how good your prosthesis seems to be. The moment you put it on a amputee, it needs to function as closely like a human limb as possible, or else it's going to be very, very difficult to control. So, for us, our technology mimics the way that human muscles move and actuate and work. And so it makes the end user experience far better than if you were to use traditional servos, hydraulics, or anything else like that.
I'll say there is still a long ways to go. The actuator is only, probably 25% to 50% of the problem. The other half or more is going to be the control system as well, right? We're going to need neural networks in order to read your muscle or neurological signals and then be able to command the actuators just like a human body would. And so our hope right now is that we can get the actuator design down so that by the time the control systems are ready, and maybe through community collaboration with this open source project, with Tori's open source project, and many others, we can do it as a community, and maybe many companies like us will sprout from that.
Yeah, if we can get the actuators down, the sensing down, and then the sensory feedback down, I think we got a killer prosthetic right there.
Yeah.
And that brings us full circle back around to you, the person watching this video. It is communities such as these where these ideas can prosper, where open source, where entrepreneurs, where great minds get together to try to make a positive difference in this world. So join us, join Delta Robotics, Ultimate Robotics, OpenMuscle, as we try to make tomorrow a better place. Till next time, and as always, let's see if we can make a positive difference in this world.